Hi everyone, I am Sridevi, Professor, Department of Electronics and Communication Engineering. In this video lecture, we are going to learn about Gaussian process and ergodic process, also the white noise characteristics. Basic things about ergodic process. Before going to the definition of ergodic process, we have to define the time averages and ensemble averages. So in an event, the distributions and statistics are not available. We can avail ourselves of the time averages from its particular sample function. Already we know that the sample function, so the output of an event is called a sample function. The mean of the sample function x lambda O of t is referred as the sample mean of the process, and x of t is the signal input. So the ensemble average is an average that is taken across the process. Such averages are taken at the fixed time incident, or at the fixed time instant, or at the instant time the average value is taken, that is called as ensemble averages. For example, the mean and autocorrelation defined in the random process is called as the examples of ensemble averages. So mu of x of t is equal to 1 by t, limit integral varies from minus t by 2 to plus t by 2 x lambda of t, that is the mean of sample function. So the quantity is actually a random variable by itself because of its value depend on its parameter sample function over it was calculated. The sample variance of the random process is defined as by calculating the standard deviation sigma. So the time average taken along the time, and the time mean is differentiated as mu of x, and variance is defined as sigma of x. So sigma square x of t is equal to 1 by t into integral minus t by 2 to plus t by 2 modulus x o lambda o of t minus mu x of t the whole square into dt. The time mean of the random process is given as mu of x, and the time average of autocorrelation function is defined as Rx of tau comma t. The quantities are in general, they are not same as the ensemble averages described. So it varies, that is Rxx of t, that is equal to 1 by t integral minus t by 2 to plus t by 2 x of t convolution with x of t minus capital T dt, where x of t is the ergodic in mean, and first order ergodic if the mean of the sample average asymptotically approaches the ensemble mean. So the definition of random process, we have to consider ergodic mean and ergodic autocorrelation. So ergodic mean is the process in mean if the conditions are said to be limit t tends to 0 mx of t is equal to mx of t, and limit t tends to infinity variance of mx of t is equal to 0. If these conditions both are satisfied, we can tell that is ergodic mean. And the concept of ergodicity is a significant form of measurement of practical solutions. So the ergodic mean and autocorrelation should be calculated, and this process is always stationary, but its converse is not true. That is, ergodic process is always stationary and stationary process is not always ergodic. The time averages is equal to ensemble averages, then it is true only if both types of averages are independent of time. When both are independent of time, we can tell time average is equal to ensemble averages. So independency of ensemble averages indicates stationary process. So ergodic process are signals for which measurements based on single sample function. That is the statements, that is it is taken in ergodic process is always stationary. It is considered ergodic process is always stationary, and stationary process is not always ergodic because of the reason For stationary process, ensemble averages are independent of time. That is why we can tell stationary process is not always ergodic. So, the means stationary process need not to be necessarily ergodic. So, next is the Gaussian process. So, Gaussian process, it is simply defined as, consider the random variable, a random process x of t. So, Gaussian process, it is said to be Gaussian distributed or Gaussian process if every linear functional of x of t is said to be Gaussian variable. So, x of t is passed through an LT, a linear time invariant system, then output process y of t is also a Gaussian process. So, for Gaussian process, wide sense stationary process and strict sense stationary are equivalent. So, the Gaussian process is a stochastic process of x of t, and it is in T, for which any finite linear combination of samples that has joint Gaussian distribution. Joint Gaussian distribution means for random variable x and random variable y, for x function only it is considered as x of t, and y function only it is considered y of t, and if it is joint means x comma y. So it should be considered like this. So the Gaussian modeling of a random process, that means it is always easier. Gaussian modeling is most suitable for random processes which are generated by physical phenomena. So the sufficient condition for ergodicity of a stationary zero mean Gaussian process x of t is equal to, that is, minus infinity to plus infinity, or x of tau d tau is always less than infinity. The joint Gaussian process can be calculated as for two different independent variables combined together, that is x of tn and y of tn, both are combined, and it will be called as combined or joint Gaussian process. So we have one quiz question based upon this random process, that is, the random process is a dash interpolation process. It is always Gaussian process is a linear interpolation process. Question again, Gaussian process is a linear interpolation process. Hope all you